Hello guys and welcome to this recitation on the fundamentals of Numpy, part 2. In our previous recitation, we covered how to set up the installation of Numpy for your working environment. We also look at how we can create an array using Numpy and some other stuff. Now we'll cover the notion of how we can access data in a specific entries. We'll look at how we can do slicing of arrays and some other operations such as modifying the data and reshaping data. So let's get started. The first thing that we would like to do here is how we can access a particular entry in an array using NumPy. So the first step of what we can do, we create here an array of 3 dimensions with 4 batches, each containing 5 rows and 6 columns. So now we'll try to get a specific entry in the array. For instance, we want to return the element located at the 4th column here and at the 3rd row of the first batch. And you can see that this is the output. Now there are a couple of operations that we can do also if we want to take like multiple entries at the same time. We could do what we call the data slicing. So to do that, we have some operators that we use. As we've created an array of 3 dimensions, let us say that we want to select the first batch from the array that we have. So we need to take the first batch and use the colon to select all the rows with all the entries. And then when we print it, you can see that we have all the rows and the entries here for this first batch. Another thing that we could do, we can also select just the first batch followed by the first 4 rows and the first 5 columns, and we try to print it. And you can see it here. Another operation that we could also do using NumPy is to try to select all the batches, but we'll just want to keep the 4th row and the 5th columns. So if you do the manipulation, you will get the output that we have here. So for instance, for the first one, you see you have like 1, 2, 3, 4, 5, 6 column. That's what we have. And because the array that we created before was with 6 column, and when you count the number of rows, you see 1, 2, 3, 4, 5 rows. That's what we've done for the first operation. We just selected the first batch. So if you do the manipulation, you can also get the same thing for the second slicing that we've done. And you will see for the third one that we did here. We were just selecting all the batches followed by just the third, the 4th and the 5th row and columns. These are some of the operations that we can do, but we can go furthermore and do like the slicing of an array, but using some steps. So if we take our array that we've created, we can, for instance, select from the first batch until the end by a step of 2. So if we do that, we'll get the output that we have here. So we slice from index 0 to the end of the dimension at interval of 2. That's what we have there. Another way, because this operation basically do what? We give the start index, the index at which we want to stop, and the step size. So what we've specified here was just the start. So the stop will be the last element, and the step size was 2. So we can also do the same thing along the different dimensions. So we can do it for the batches. We can also do it for the rows and the column. That's what we applied here. So we selected from the first to the last batch, by step of 2. And we also selected from the second row to the 5th. And we also apply that kind of operation on the columns. So you can see we selected from the rows 2 to 5 and columns at interval of 2, and then we start from the index 1. So, and then we get the output that we have here. This operation that you just we just show you here will help you a lot because, for instance, if when you will be working on your convolutional neural network implementation later, you will see that some of the operation like the downsampling or maybe upsampling that you will be doing will need you to do some kind of slicing and to take some specific entries for your convolution work that you want to do. Okay, so now, apart from that, there are also other operations that we can do, such as modifying data, because I would like to modify a specific entry. So how do we do that? Let's first start by taking a copy of our original array n. So when we take the copy here, we use the function copy from the Numpy package, and we can copy this array into a new variable that we can manipulate later. So after doing that copy, if you compare the entry from the copied array with the new one, you will see that they all have the same entries. So when we do the comparison here, you'll see that the output is true. But now that we modify the entry from the new array that we obtained after copy, you see that when we compare again these two entries, they are no longer the same. So it's a real copy that we have. If you want to modify now multiple, this one just help us to know how we can modify a single entry. But if you want to modify multiple entries at the same time, you just need to select the array, the content, the array's content that you want to modify. You just need to select the different entries, maybe using some dimensions, and then you assign the value. So here, for instance, what did we do? We have an array of dimension 3. So we want to modify we selected the the third batch and the fourth row. And we want to modify all the values for the fourth row. So how do we do? N copy of 2, 3. We are assigning the value of 0.5. So all the elements on that row will be with value 0.5. And you can see that before modifying, all the entries at this specific location are the same. So when you compare two entries of an array, it will just state whether the logical operation that you are doing is true or false for each of the entries in the selected entries. So we can see that they are all the same. Then before modification, these are the values that we have for the array. But after assigning these values to that row, all the rows now take this specific value. All the values on that row take these specific values. And when we compare it again to the original data, you'll see that they are not the same. So these are some of the operations you can do easily with NumPy. But we can see other operations such as how we can pivot data, because this is useful when we need to do some multiplication operations, or maybe we want to fit maybe some part of our network with specific data. So we can use these operations. So how it works, basically pivoting the data here, sorry, will just be a kind of reshaping the data. So there are a couple of ways we can do it. So the array reshaping is an operation that changes the shape of the array while maintaining the same data in the array. So the data will not change. The data in the arrays will not change, but the shape of the data can change. This can take your data in specific entries to another location depending on the new dimension of the array that you have. Okay, so let's take a new array here. We just generated an array with random entries. So an array of shape 3, 4, 5. So 3-dimensional array. And this is what we have. the original array that we've created. Now let's try to reshape the array. But one specific rule that we follow when we are reshaping array is to make sure that the new dimension that we are giving to our array, the new shape, when we multiply all the dimensions values, they should be the same, the output should be the same for the original one. So for instance, we have 3 by 4 by 5. When you do this multiplication and you do 2 by 6 by 5, you should have the same result at the end. So if we reshape this original data, you will see that we get this one. So this will now be an array of 2 batches. You see, we have 2 different batches. Before we have 3 batches, we have this first one, this second one, and this third one. This is 3 batches, followed by 4 rows. So each one of the batch have 4 rows. They has 4 rows. They have 4 rows, and we also have 5 columns for each of them. But when we turn it now into 2 by 6 by 5, you'll see that we have 2 batches with 6 rows and 5 columns. So this is how we can reshape. So to do that, we use the reshape function on the specific object that we want to reshape. So the next operation we can also do will be reshaping our array in different number of dimensions, because what we've done here, we just reshape the array from the same dimension to a new dimension, which is of the shape are not the same, but we are still in the same dimension, like 3. But here, let's create an array of 1 dimension here. We have an array of 1 dimension with 120 elements here, as we can see. So when we take this and we want to reshape, we can transform this into a 3-dimension array or 4-dimension array, depending on the name that we have. So here we want to reshape the data into 3 dimensions. But as I've already stated, when we do the reshape operation, the product of the different dimensions should give the same number as the original data. So if you do 3 by 4 by 10, it's always 120. And when we do that, you see that the same data will be here, but this operation will be done following the rows here. So that's what you have. So we have now 3 batches, 1, 2, and 3. And we have 4 rows for each one of the batches, 1, 2, 3, 4, 1, 2, 3, and 4. And we have 10 columns for each one of them, 1, 2, until, and you have 10, and it's the same thing. This is one way of doing it. If we want this data to be reshaped again into 2 dimensions, we can also do it. And you can see that when we do that, here it's now 6 by 20, and the shape, when you do the product, 6 by 20 will be giving you 120. This is another way of how we can pivot the data from dimension to dimension by using the reshaping. But when we are doing matrix multiplication, which is something we'll be doing a lot in this deep learning class, we sometimes apply the transpose operation. So what is the transpose operation? It's the normal transpose operation you learned before if you already did some linear algebra. So it's the same thing, but we have a couple of way of doing it here by using the transpose function or some other operators that we'll see. The transpose operation reversed originally the order of an array. That's what we know. Then it will switch, if it is 2-dimension array, this will switch the rows to the columns and vice versa. In multi-dimension array, the transpose operation moves the data from one axis to another, and in the order specified in the transpose method. So we'll see how this works in a few steps. First, let's create an array. So an array of 50 elements, and then we'll reshape it to 2-dimension automatically. So it will be 5 by 10. It's okay. So this is our original data. Then we want to transpose. It is a 5 by 10 array. So if we do the transpose operation, this will now be 10 by 5 array. So that's what we have here. So after doing the operation, we now have this with 10 rows and 5 columns. So this is one of the way we can do it. Now let's see what other operation we can do with the transpose operator. So when you see here, I was saying we use the transpose function from Numpy to do that, but we can also use the T operator. This automatically do the work for us. But here we do not specify the axis when we are doing it. So that's the output of the last output that we have here. So now let's create a new array of 60 elements, and we reshape it to 3 by 4 by 5. So it's still with 60 elements. Is it okay? We already know how we do the reshape operation and some of the rules that applies to that. Is it okay? So we want to reshape using this new shape. We've done it, and we have a new array here, which is our original array. So we want to transpose the array. So if we do not specify any axis, this will just transpose the element by changing the column to be now the batches, and the batch will now be the columns. That's what is doing here. But if we do not want it to be that way, we can specify what axis this transpose operation should do. Like what are the axes that the transpose operation should follow, or maybe stick on to do the operation. So we can do that just by specifying the axes. So here we do the np.transpose operation, but we'll tell the function that, okay, the first axis our first axis now will keep being the same, but the second axis, which is the row, now will be the third axis, which was our column, and then the row will become the columns. That's what we've done here. And we can also change it later and say, okay, now we want the first axis to be the second dimension, the second axis to be the third dimension, and then the last axis to be the very first dimension. And then by doing that way, this automatically do the transpose operation for us, as you can see here. So you can take some times to compute it and go through to see how the transpose operation is done. Basically, we know that we specify the axis, but you will see how the data change inside the arrays because this is not a big array. Another interesting things that you will need to do here, basically, suppose that you have an MLP and you want to feed into your MLP a vector, but your original data is an image, for instance, which is maybe 2-dimensional or 3-dimensional arrays. You will maybe like to get this data into 1 dimension to be a vector before you feed into your MLP. So how do we do that? We'll need to take this data and flatten it into 1 dimension. And that's what we want to see here. So the flatten operation in NumPy collapse array of multi-dimensions into 1 dimension. So different orders can be specified when flattening the NumPy arrays, and we'll see it in the example that will come in the next steps. So let's start by creating an array with random entries, an array of 5 by 6, and then we'll do some operation on that. So if we want just to flatten along the rows, along the rows, so what it will do, it will take each rows followed by each rows and so on to the end. So if we do that, we know that our array was 5 by 6. So when we flatten it, we'll get 30 elements in 1 dimension, and that's what we see. So we use the flatten function on the object that we are manipulating, and you can see the output is now this. And this basically follow the order of element in the rows. But if we do not want it to be following the rows, maybe you want it to be follow the columns. So this will take column by column to do the operation. And to do that, we'll need to specify the parameter here, which basically do the flatten operation by following the columns. So this is another way of doing it, and you can get the output here. Now, instead of just calling the flatten function, we could also use the reshape function to do that. And how it works. So if we want to flatten the data, we can just do the reshape, but just by giving the shape which is -1. This will automatically flatten your data to one dimension, and you get the output which is here. Let's look into this last operation, which is really helpful, is how we can squeeze an array or maybe expand these arrays later. So it is useful maybe when you go through some manipulation during this class course, you will see that sometimes you need to squeeze your arrays into some dimension and work with it. But the squeeze operation, which allows us to do the reduction of Numpy arrays, is done by dropping a specified axis. So if it is not specified, this will drop the axis that has the unit length. But basically, we need for this operation to work, if you want to do the squeeze operation, we need to have at least one axis with unit length. So that's how it works. So the product of the shape over the overall shape will still remain the same when we do the squeeze operation. So suppose that we create an array of here like this, 4 by 1 by 5. This is the original array that we have, which is here. So we can squeeze the array. When we squeeze the array, the axis with the dimension 1 will be removed, and the array will become, the data will remain the same. And we just remove the axis because it's not really necessary in the work we are doing. And then we get the same data inside, but the dimension now will change. So this is 3-dimension array. When we squeeze the array, this will become 2-dimension array. The axis with the unit length will be dropped out. But if we do not want to do it that way, we can specify the specific axis that we need our operation to follow. Suppose that we have two different dimension with unit length. We can just specify that we want to squeeze this one, and it will work that way. So here, for instance, we specify that the axis is 1, and it just works. Now, after squeezing the array, we can unsqueeze the array. The squeeze the array can be unsqueezed later. So the operation will be now to expand. But for that to work, we need to specify the axis. So if we want now the unit length to be axis 1 or maybe 0 or maybe 3, we'll specify it and give it. So by doing that, here you will see that we do the operation. We first create the array of 2 dimensions. And then here we expand the dimension by giving the array using the expand dimension function from Numpy, and then we specify the axis. So this will automatically take the array that we had and now expand by creating a new axis of 1 dimension, which is the axis that we specified. So we can do it by specifying multiple axes, and you can get the output which is here. So we created this array. By doing the first expand, we get this output. And by specifying 2 different axes, you will see that we get this output, which is here. So thank you for watching this recitation. We are at the end of the second part of this NumPy's fundamentals. In the next, we'll see how we can combine data from different arrays, and also go through some more interesting operation that we'll be using in this deep learning class. Thank you for watching, and see you in the next.